Hello everybody. Hey, so we are now going to go in our book to page 232. And what we're going to do is we're going to talk about Newton's law of universal gravitation. So in here, with this one, what you're going to do is the first thing we're going to do is we're going to look at the ones on the right first. That's my one pager. So if we're talking about this here, we're talking about Newton's law of universal gravitation. It talks about Isaac Newton discovered that centrifugal force holds planets in its orbit. And it was talking about a cannon on top of a hill and how it shoots. According to the parabola, it has to do with the angle that it's shooting the cannon, which is not moving, and then the distance. And as it says here, with distance, it actually increases the speed of the projectile, which makes it go further. So it gave us this equation, which is gravitational force equals G, which is going to be a constant, mass 1 and times mass 2 divided by the distance between the mass squared. So on here, most of the time, if it doesn't say, G is going to be 6.673 times 10 to the negative 11 newtons times meters squared divided by kilograms squared. And that is the units there. Okay? So, it talks about how the Earth has a pull onto the moon and the moon has a pull onto the Earth. And it gave us a sample problem. And it says the sun has a mass of 2.0 times 10 to the 30 kilograms. And the radius is 7.0 times 10 to the 5th kilogram, which I'm going to change to meters, okay? What mass must be located at the sun's surface? The gravitational force of 470 newtons. So that's our force gravity. And we're going to use our constant like we have for G. Unless exist between the mass and the sun. Wow. So, we have mass 1 at 2.0 times 10 to the third kilogram. We have our radius, which we changed, of course, to our meters. We have our gravity constant, which is that, and then our force gravity. So, what we're going to do is we're just going to put this into the equation. So, the first thing I'm going to do is alpha y inner, and that's going to be 470, 7.0 times 10 caret 8 over a closed bracket squared down. And now what I need to do is I need to put this in. So open bracket 6.673 times 10 caret negative 11 over closed bracket open bracket 2.0 times 10 to the 30th power. I just want to make, for some strange reason, it just looked weird because it had the 30th power. Close bracket and then hit enter. 1.7265610E0, which I'm going to change to 1.7. So, let's get to the problems that we have. So if you'll turn the page, it talks about the black hole, but if you go ahead and look at the bottom, it says a passenger liner, Carnival Destiny, and Grand Princess has a mass of about 1.0 times 10 to the 8th kilograms each. How far apart are the two ships that exerted a gravitational attraction of 1.10 times the negative 3 newtons on each other? So, we're going to use our constant again. This time we're going to just do the square root of this. So what we're going to do is we're going to do square root. We're going to open our bracket. 6.673 times 10 and then caret 11 close bracket. Remember, all of that is just units, so we don't have to worry about putting all that in, and so we don't have to put anything on the outside because it's all on the inside. Open bracket 1.0 times 10 caret 8 over close, but this time, see, it's going to be squared this time. So I'm going to put my square in. And then I'm going to go down to my other part, which I did alpha y equal, didn't I? Okay. So, start over. Sorry, I didn't do alpha y equal. So, first of all, square root. Then we're going to do alpha y enter, get my fraction, open bracket 6.673 times 10 caret negative 11 over, close bracket, open bracket, 1.0 times 10, and I'm going to do caret 8, and then I'm going to go over and I'm going to close my bracket. Now, it doesn't say anything here or up there that, which is my 4 square, over 1.0 times, and I'm going to do it without the square to see if I'm right or wrong, because I think I just wrote it wrong, times 10 caret negative 3, okay, and then I'm going to hit enter, and it is without the that 2 is supposed to go on the inside. Sorry, guys. So that is 2.6, and that's going to be without any exponents. So let's go back up, because I think it does need to have it. God bless. So if I go, I'm learning how to use this calculator so well, I promise you. So I'm going to go over here, and I'm going to go ahead and add a square to it. And it does. It has to have the square. So then it's 2.583 to the 4th power. Okay. So then what I'm going to do is I'm going to change that to normal mode instead of scientific. And I get 25832. So I'm going to just change that to 26 because that is the closest thing that I've got. And then I'm going to go to the next problem. The next problem is pretty long. So, no, C is very long. 3 is very long. Jupiter is the largest planet in the solar system, has a mass of 318 times the size of the Earth. The volume is 1,323 times greater than the Earth. Calculate the magnitude of gravitational force exerted on a 50 kilogram mass on Jupiter's surface. So, the first thing I'm going to do is I'm just going to get all my information. Where am I getting my information from? It's just based on what the problem is telling me. And then also I'm looking at question number 3. So, here you will see this little thing right here. This here is awful exciting in the calculator. So, I'm going to show you how to do this problem. And hopefully I'll do it right the first time. So, alpha y enter. So I'm going to do 6.673 times 10 caret negative 11 over, close bracket, open bracket, 318, close bracket, open bracket, 5.98 times 10 caret 24 over, close bracket, open bracket, 50, and then close bracket. Here is the unique one, okay? So, to be able to get this, what you're going to have to do is, I'm going to start off with this first, and then I need to get this a 3 square root of. So, I'm going to go to math, number 4, okay? And then I'm going to put in my 132, 1323, and I'm going to close my bracket. Open my bracket, 6.37 times 10, and that's caret to the 6th over, close, close, and square. And I get 1.5 times 10 to the 12th power. So let's go on to our next problem. number 3. And I'm just going to show you number 3. I'm not going to step you through it. So if you need to stop the video to see how you do A, B, and C, because what we're doing is predicting the magnitude and the gravitational force of 66.5 kilogram person would experience while standing on the surface of each of these celestial bodies, and this is the answer. And so then the next part is where we're having Newton's law, and it's talking about how Newton's law is accounted for ocean tides. It's talking about how the tides use the moon, and how the moon makes high and low tide. So you will need to make sure you understand that the moon does have that. And then if you want to talk about it, high tide is when the earth is lined up with the moon. Other factors of changing affecting the tide is ocean basin, earth tilt and rotation, friction between the ocean water and the floor. Sun does affect, but not as much as the moon. And then the last thing I want to talk about is I want to talk about this diagram right here. So what he was trying to do here is he was trying to find out how they found G. So this one here is where you only have the light source, the mirror, and then you have a fixed celestial body, okay? So in here you have 2, that's the moons there, by the way. These here you have your moons, but they're moving, and the sun, and then 2 more celestial bodies, and how they figured that out. So that's where they got G equals Fg divided by M. And the last thing I want to talk about is free fall. Gravitational field strength is gravitational force that would be exerted on a unit. Sorry, I turned it. Mass at any given point in space and is equal to a free fall acceleration. So that is all I have. But before we go, let's go back to this problem again. Of course, like I said, I was going to try to get through it without making a mistake, but guess what? I forgot to put the square on here. So if I did put the square on here, I am going to get the 1.3 times 10 to the third. And guys, I promise you, I am done making movies today for you. So I am completely caught up. So I hope you have a great weekend. If you don't see this until you get done, I will see you on Monday morning. Have a good day.